Hi, welcome to Zona Mechanica. There is a numerical answer type of question. The figure at the margin indicates the weightage of the question, that is 2 marks. So the solution of this question will be a little bit longer. Well, there is a block. There is a block of weight 200 Newton and it is resting on a level plane, horizontal plane, and the force P is acting on the block, horizontal force. The surface is rough. The coefficients of static and dynamic frictions are given 0.4 and 0.2 respectively. The question is, what will be the velocity in meter per second of the block attained after 10 seconds? See, the force P is given in terms of t, that is time, in seconds. So the P is a variable and it depends on time. So P is given like P is equal to 10t. That means P increases as t increase. T is increased. So if this is t and this is P, so when t in seconds and P in newtons, okay, so if t is 1 second, so what will be P? 10 Newton. If 2 seconds, then 20 Newton, right? So likewise, if it is 8, then 80 Newton. If it is 9, 90 Newton, so and so on. So like this. Suppose the frictional resistance acting on the block is F. So clearly, before starting sliding, the block will experience maximum limiting friction or static friction. So let Fs be the static friction, that is mu s into n. So mu s is 0.4 into 200 Newton. So since the weight is 200 Newton, the reaction will be the same. So that is 80 Newton. So this is the limiting friction. That means up to this 80 Newton, the P, if we gradually increase the P, see like T is increasing, so P is also increasing, and once it reaches 80 Newton, then only it will start moving. So that means at 8 second, okay. And if the Fk be the kinetic friction, then mu k into n, okay. So mu k is 0.2 into 200, so that is equal to 40 Newton, okay. So we have to calculate the velocity in 10 seconds, after 10 seconds. So what will be the net force acting on the block? See, P is acting in this direction and F is acting in this direction. So the net force F net will be P minus F, right? So from Newton's second law, of motion, so we can write down that F net is equal to m into dv dt. M into a is nothing but dv dt, so a is equal to dv dt, okay. So a is the acceleration due to acceleration of the body due to this net force. Okay, so net force, how much is the net force? P minus Fk. Once it starts moving, so the frictional resistance will be kinetic friction. So m is m into dv dt. So that implies P is nothing but 10t. So 10t minus Fk. Fk is 40 Newton is equal to m into dv and dt here. So now we have to calculate the velocity attained after 10 seconds. See, at 8 seconds the block starts moving, so we have to concentrate on from 8 to 10 seconds, right? So from 8 to 10 seconds we have to integrate 8 to 10 seconds, 10t minus 40 dt is equal to m into v1 to v2 dv. Suppose v1 is the initial velocity and v2 is the velocity at 10 seconds. Okay, therefore, so this implies 10 t square by 2 minus 40t. So 8 to 10 is equal to m into v2 minus v1, right? So v1 is 0 since it starts from rest. So if we put 10, so this will be 5. So 5 into 10 square minus, this is 400, minus, if we put 8 here, so this will give 0. Okay, so this is equal to m. M is nothing but mass of the block, so that is 200 divided by 9.81 into v2. Therefore v2 will be equal to, so this is nothing but 500 minus 400, so 100, so 200, sorry, 100 into 9.81 by 200, so that is equal to 9.81 by 2, so this is equal to 4.905, so almost equal to 4.9. See, since it's a numerical answer type of question, the answer is given in range. So range of the answer for this question is 4.8 to 5.0. So our answer 4.9 is within the range. So this is correct answer, right?